Before we go to the next section, which is on learning, I just want to introduce the concept of errors and error surfaces and tell you how it relates to these multiple solutions that we were talking about. So for simplicity, what we'll do is we'll just set the threshold to minus W to 1, which is setting the threshold to -1. And now I'll try different values of W1 and W2. Okay, so I was saying that there are multiple values of W1 and W2 possible, and these are all real numbers, right? We are not constrained by having them as Boolean values. Okay, so now this is one solution which I tried. I tried setting W1 to -1 and W2 to -1. What is wrong with this line? Does it lead to any errors? How many? Just one error, right? So this makes an error of 1 out of the 4 inputs. Now let me just try some other values of W1 and W2. Okay, this line. Again one error. Okay, what about this line? Not 4, 3, because 0, 0 is anyways on this side of the line. Okay, so now given this, now tell me that my quest is to find these W's, right? I want to find W1, W2 and so on. Now given this discussion on errors, can you tell me a condition that I'm looking for? I want to find W1, W2 or up to Wn such that errors are minimized and in the best case errors are 0, right? So that's what I want, right? So this, just I want to make a case that the search for W's is driven by certain objective, and this objective is to minimize the error. Okay, fine. So now since we're doing this, let us plot the error surface corresponding to different values of W0, W1 and W2. And once again, for simpler analysis, we'll just keep W0 to be fixed at -1. And now what I have, so just don't read this bullet as of now, even this one. So I have this W2 here, so that's my one axis, and I have W1 here, which is my another axis. Okay. Now what I'm going to do is, I'm going to try different values of W1 and W2. So this axis can go from -infinity to +infinity. Of course, for the sake of showing here, I've just had it from -4 to 4. Okay. So now what I'm going to do is, I'm searching for some values of W's, W1 and W2, so that my error is 0. And let's do a brute force, right? I'll just try every value between -4 to 4. Okay. And in fact, one of the solutions which I proposed actually was this 1.1, 1.1, right? That's the line which we saw on the previous slide and which led to 0 errors. And that's the dark blue surface here. So how did I compute this error? Actually, I just substituted 1.1, 1.1 here. And then I put in all the 4 values combinations for x1, x2, right? And I realized that I'm able to satisfy all of them. So I don't get any error, right? Now instead of that, if I had put something different, so let me just go back to the previous slide, which was say -1, -1, right? Which is, I think, somewhere around here, right? -1, -1, I guess. So for that, I am in this light blue region where the error was 1. So I make errors for one of the inputs, right? So it's a very brute force way of finding this, and this is not going to work, right? Because we have lots of inputs to check. But this is just to give you an intuition that we're looking at errors and we're trying to find a value of W1, W2 which minimize this error. Okay? So that's the idea behind errors and error surfaces.